All right, students. So this week we're going to cover chapter 2, which is about research methods. So let's talk about the difference between what's called correlational research and what's experimental research. Okay. So first, starting with correlational research. What correlational research is it's when we conduct research to find out about the relationship between two variables. And a variable is just any value that is being looked at or measured or examined in some way. Okay, that's what a variable is. So for instance, we might have like a correlational research that's looking at ice cream sales on a hot day, right? So we're looking at the temperature, that's variable A, and we're looking at ice cream sales, that's variable B. And we're looking to see if there is a relationship between these two variables. Now, something you need to understand is that correlational research is only looking at the relationship. It is not creating a cause and effect. In other words, variable A is not causing variable B in this type of research, or at least we don't know that, okay? Because we only know whether it has a relationship with each other. Is something happening? Does one go up and the other go down? Does one go up and the other go up? Do they both go down? Nothing happens at all? Like, how does that work? Okay? Now, some examples of correlational research are going to be observational studies, such as naturalistic or laboratory studies. So, like, if we're out in public and we're watching people and we're, taking marks of whether they're, performing certain behaviors, like maybe you go out and you want to find out like how many people look at their phone while they're walking, right? So variable A is walking, variable B is looking at your phone, and you're marking like how many people do, how many people don't, right? And so you're recording this, and so you're researching. That's a naturalistic observation. Now, the problem with a naturalistic observation is if people know you're watching, what are they going to do? Yeah, they're going to change their behaviors. That's right. They're going to change things up. They're going to go, wait, that person's watching me. Let me put my phone away, right? So that's a problem in naturalistic observations. There are ways to counter that. You'll read more about that in the book, okay? Now, laboratory studies are when we bring people in and we put them in a room and we want to observe their behaviors. We do this often with like parents and children or just children, and we want to observe the child's behavior and see if there's some type of relationship. So let's talk about like parenting and the child's behavior. We want to see if parenting, the way the parent is parenting, is affecting the child's behavior. Variable A, variable B. We want to see if there's a relationship, okay? Problem with laboratory observations, we get false behaviors a lot. Again, people are under observation, they tend to change, they tend to be different, okay? Case studies, another correlational research, all right? A case study is when we take one person, okay, and we collect as much data from that one person as we can. Such as like a very famous one is Genie, Genie. You can read about that more in the book too. And so Genie was neglected and she was abused and mistreated. And, when the police did find her when she was about 13 or 12, I forget what the age is, but she didn't speak. She didn't know language, right? And so we are able to observe her behaviors, watch her behaviors, see if she learns language at this time, see if there's a time where people can't learn language, but it's only that one person, right? So we can get a lot of information from them, but we cannot generalize it to everybody else because it's just one person. It's a very small sample size, right? And whatever happened with Jeannie, it may not be the same with another person, and so we need more sample sizes to like figure that out, okay? Case studies are great because they provide us a lot of information, but the downfall is we cannot generalize these case studies to everybody else, right? We have this right now with, let's say, like the COVID situation. People are like, well, my one friend went here and nothing happened to them, and they traveled there and nothing happened to them. So maybe it's not happening to anywhere, and it's like, well, that one person, right, is not a generalizable sample of everything else. Okay, you understand? So that's one of the downfalls. Next, we also have surveys. This is also a correlational research method. Okay, we've all participated in surveys. All right, they're everywhere, especially with the internet now. Very easy to give a survey and collect data, and we can get a large amount of data from surveys. And we can also get a representative population or representative sample of a population, which means that the sample we get, the people who take the survey, often represent the entire population that we're looking at. So we have a good chance of doing that with surveys. The problem with surveys is, what do you think? Yeah, people lie, right? People don't tell the truth. So imagine you're taking a survey that's asking you about sexual behavior or asking you about drug behavior, right? Like, often people don't tell the truth. Even though their name is nowhere on that survey, it doesn't matter. They don't often tell the truth, okay? And so that's one of the problems with surveys. Also, interviews are considered surveys as well, all right? Now, the reason why correlational research doesn't create a cause and effect relationship, it only shows us the relationship that's occurring, all right, is confounding variables. So remember, a variable is any value or anything that we are measuring or anything we're examining, okay? Confounding is that it is out of our control. We do not control for certain variables, right? So like ice cream sales on a hot day, right? So temperature goes up, ice cream sales go up, okay? So we can see that there's a relationship occurring. But we're not factoring in things like maybe there's an ice cream shortage, or maybe a particular brand is on sale right now, or a particular brand is going out of business that people love, so they're buying all the ice cream, right? So we can't just sit there and go, oh, well, because ice cream sales went up and the temperature is going up, that means that there's a cause and effect. We can't do that. That's where experimental research comes in. That helps us create the cause and effect, okay? Now, let's talk about how we actually plot this data and kind of understand what's happening, all right? So we use scatter plots for the data that we collect through correlational research. As you can see here, the XY axes, right? So we use scatter plots. And you can see that we have a positive, a negative, and then a none. What this means is this scatter plot is what's called a positive correlation. A positive correlation is when one variable goes up, the other variable also goes up. So ice cream sales, hot day, right? Ice cream sales, temperature, okay? That's a positive correlation. A negative correlation is when one goes down, the other goes up, right? So let's say this is sleep. So as people get less sleep, the tiredness of what they're feeling, right? The feeling of tiredness goes up. And you can see here that we have our diagonal line that represents one going down, one going up. This diagonal line represents one going up and one going up, okay? So positive correlation, negative correlation, and you can probably guess what the last one here is with none. That means that there is no relationship. We cannot see a relationship. There's nothing actually occurring between these two variables. So let's say it's like, tiredness and foot size, okay? So tiredness and foot size, there's no relationship, right? There's no connection happening at all right? Now it's very important that I want you to understand correlation does not equal causation. When you're reading research or you're reading news articles, right? This is all about critical thinking. When you're reading these things, you have to remember correlational studies like this do not equal causation. We cannot say A cause B. We can say there's a relationship. There is a connection between the two, but we cannot say A cause B. But if we do an experimental research study, now we're looking at cause and effect because we are creating an experiment. Okay, we're creating these groups. So we have experimental groups and we have a control group. The experimental group is the one that we're manipulating, we're messing with, we're giving the variable of whatever we're manipulating, okay? And then the control group is the group that we're comparing the experimental group to. Okay, and I'll go through this even more. Now, when it comes to variables, we use what's called an independent variable. So this is the variable that the researchers are manipulating, okay? And then we use a dependent variable, which is the variable that the researchers are measuring. And when we put people into groups, we actually randomly assign them into the groups. So we're not hand picking them. We just randomly assign them into the groups. They don't know what groups they're in. That's usually how it is. And even sometimes the researcher doesn't know. Okay, that's called a double-blind study, when the subjects don't know what group they're in and when the researcher doesn't know what group the subjects are in. So there's no bias or any treatment, like different treatments being different way of treating the participants, okay? Like a researcher, if they know they're in the experimental group, they might treat that person different than the control group, okay? And our subjects often try to figure out what group they're in, and that creates some problems too, okay? You'll read more about that in the book. But let's talk about an experimental research. So let's say we're testing a new antidepressant, and we want to create an experimental research to find a cause and effect. Okay, so we pull together as, let's say, 100 participants, right? And then we divide them, randomly assign them into an experimental group and a control group, okay? Now the experimental group is going to get the medicine. They're going to get the actual pill, the real medicine. And the control group is going to get what's called a placebo, which is, it's not the real medicine, but it does interact with the people. The best placebo will actually have the same like side effects, but it will not have the active ingredients, okay? That way the person doesn't know what they're getting. So the independent variable would be the medication, all right? That's the variable we're manipulating. Experimental groups get the medication, control group gets the placebo. Then, at the end of the study, the dependent variable, which is what we are measuring, so at the end of the study, we measure the people's level of depression. Did it go up? Did it go down? What's happening, right? And what we're really looking at is the experimental group. Did something change with the experimental group? And then we take whatever happened here and we compare it to the control group. Did something happen with the people in the control group? Okay? A good study would show us that the experimental group, all right, had less depression or less symptoms of depression, and the control group had no changes. That would tell us that the medication was working, okay? So I hope you understand what I'm saying here. So this is the experimental group.